Okay, how's everyone going? All right? Good. Excellent. So, everyone here today has ingrained into themselves a very powerful reward system. Every time you do something that you've done previously again and you feel good, this is our body giving us a reward. Now, the reward system inside us is so powerful that it forms a very important part of our habit loop. And there are three parts of a habit: the cue, the action, and the reward. And when we woke up this morning, we all brushed our teeth because it's a habit. The cue is waking up in the morning and having that kind of dirty feeling inside your mouth. The action is putting the toothpaste on the brush, brushing our teeth, and the reward is that nice minty feeling that we feel afterwards. Or depending on the flavour of your toothpaste, I don't know. So we wake up the next morning and we do the same thing because, there's the cue and there's the reward and there's the action. Now, social media platforms are built in such a way where they harness these three aspects of a habit: the cue, the action, and the reward. The cue could be boredom. It could be building your massive solution and checking social media. The reward is your reactions that you get from others, your retweets, your likes, your people commenting on your things. So there's these three aspects in social media platform that can make it a habit. Now for me, social media became a time-consuming habit. And I want to stop here and say that this is me, and it may not necessarily be you. And as humans, we're all different, but at the same time, we're actually quite the same. So I decided that I wanted to reduce social media and focus on one thing in particular. Apart from trying to focus on becoming a better developer, I wanted to focus on increasing my brand awareness. Now you may be thinking, okay, what's going on? How can you reduce social media but want to increase your brand awareness? Isn't there a contradiction there? At first there is, but hear me out. You see, I was only going to post on social media when I'd written a blog post, or after, say, I've spoken at a meetup or a conference such as this. And when you go from checking social media and posting social media from a daily basis to a weekly basis, and you don't actually do these things that often, speaking at meetups, writing blog posts, it is really a change in mindset. But what ended up happening was that when I did write a blog post or did speak at a meetup and I did post, the reward that I got actually felt better because I was less used to the reward from people reacting to my posts. So I became more sensitive to it. But also the reward was a real reward in the sense that I'd worked hard for something. So I'd written a blog post, or worked hard for it, posted on social media, got people agreeing, disagreeing, reacting to it, and it felt really good. Eventually I got into this habit of looking out for areas where I can share with the community certain things, my experiences. And I generally think this made me a better developer. In the last year, I've written more blog posts than I have my entire career, which I thought, for me, giving back to the community was pretty good. One of the other things I noticed, though, maybe subconsciously, or I wasn't really working hard for, was these things. Does anyone know what this is? Surely someone has seen these before. Logs. Started noticing logs more. And it's amazing when you don't check social media in between your builds and releases, you notice these things more. It's pretty cool. And what ends up happening is you start noticing patterns inside your logs. And you kind of become like a machine learning, like you kind of see patterns going on there. It's pretty crazy. And you diagnose problems quicker. And by diagnosing problems quicker, I was able better to fix problems. And I didn't really notice this until far later, a few months after I reduced social media a few times a week. I generally thought this also made me a better developer. Now, this wasn't the only thing that changed in my day-to-day life. Obviously, the more time I had, from not kind of diverting away from social media, the focus was good. But I thought I got better at code reviewing as well. And this is just a theory, and hear me out. And if it's out of whack, just let me know afterwards and we can discuss it. But you see, social media platforms like Facebook, Twitter, and I'm probably never going to get a job at Facebook or Twitter after this talk, and like the code review platforms, whether they be GitHub or VSTS or Azure DevOps, whatever they want to call it, are built in a different way. Like, they're fundamentally different. Like, your social media platforms are kind of like a fire and forget, like, I don't know, like Kafka or Azure Event Hubs, and you're firing away to many people, and you don't really care who you're firing this to. It's just like, I'm going to go, that's it. Whereas code review platforms are, by their very nature, blocking. You're addressing one person and you're blocking, and you really care what the other person thinks. So when I started to write comments on these social media, on these PR platforms, I was kind of being more empathetic. I was using the first person why, providing a bit of context, understanding. At times I'd type a comment and be like, okay, you know what, I'm not actually gonna press comment on this one. I'd call the person over, the other developer, and be like, okay, let's discuss this. And I got better at this. I got better at code reviewing, and I realized it wasn't just about criticizing, it was about learning as well, and understanding, and providing the right way to criticize. Other developers began to be more receptive to my comments, and this part of my work made me a better developer. You see, social media platforms are different than PR platforms because they're smarter as well. And social media platforms, their algorithms are built in such a way where they recommend that you follow people similar to you or similar to people you already follow. That's the way they're built. And I've been in the Microsoft space my whole career, so I naturally have this Microsoft bias. And one of the things that happened after a few months of not having social media was I found I was a bit more open to alternate technologies, whether they be alternate targets like Linux or alternate architectures and ways of doing things that may not be recommended by your MSDN documentation, which we know is the best, yeah. So I thought this was good for me as well. I saw this kind of change in behaviour of understanding other people, being able to give them a chance. Now, I didn't just go out and accept, any JavaScript framework that came out 2 seconds ago. No, I wasn't doing that. But at least there was that openness to converse and be like, okay, what's going on? Oh, there's different ways of doing things. And if anything, it expanded my way of thinking. And I thought this was a positive for me. But perhaps the biggest thing that I saw change within myself was that I had a more genuine curiosity about people. Checking social media maybe a few times a week, you miss out on a lot of things. I take a look at my feed sometimes. It's like marriage, kids, mortgage, divorce. Like, it's just like, it kind of repeats itself. But people became more than just those things, those main events for me. I wanted to catch up with them to see what was going on, not just the big events. Because sometimes it's those little events that shape their personality and the character. And that curiosity within me made me a better person generally and a better friend, and not just a better developer. In the end though, social media is just like any tool out there. You've got to use it wisely, use it appropriately. What I've just told you is unique to me. And, I'm Raph, I'm different than all of you. But humans, we're all different, we're all the same, as I've mentioned. Nevertheless, I want to challenge you. Reduce social media, maybe to a few times a week, and see how you go. If you find you're not improving, go back to your old habits. But if you find you are improving, be sure to thank me by following me on Twitter, connecting with me on LinkedIn, and doing a little thanks and a tweet so I can repost it and get my dopamine hit. Thank you.
All right. So, hi everyone. I'm Chris, and I want to talk to you about happiness. Because happy developers are better developers, right? If you're feeling stressed or maybe upset over something, it's only naturally going to be harder for you to do your best work. And of course, happiness for you could be about any number of things. It could be about having a really supportive team at work. It could be about having realistic goals and deadlines that don't put you under too much pressure. It could be about having all sorts of different learning opportunities to help you grow in your professional career. Or, honestly, any number of other things that are important to you. There are so many different factors that have such a big impact on how happy we are. But today I'm not actually here to talk about the big things. Instead, for my time here today, I'd like us to focus on the little things which can still have a big impact. For an example, how about your keyboard? Now, a keyboard alone probably won't turn you into this disconcertingly excited office worker. But it could make more of a difference than you'd think. Bear with me for a little while and I'll tell you how I improved as a developer when I started caring more about my keyboard. So for a long time, I used just a bog standard keyboard like everyone else. I'm sure we've all used a keyboard like this at some point. But one of my coworkers at a previous job, they had a mechanical keyboard. Now, in case you're not familiar with mechanical keyboards, the idea with these is they're functionally the same as any regular keyboard, but every single key has a distinct physical switch inside it that you have to press down in order to activate the key. You might also know these as the keyboards that make the really loud, like clicky sounds from over the other side of the office. Now, my coworker at my last job, they really loved their keyboard and they used it all the time. But for a long time, I wasn't convinced. I just thought a keyboard's a keyboard, right? Like, how much of a difference can it actually make? But fast forward a little bit later, and I got myself a new job, and I got my first new job paycheck. So I thought, okay, this is the best time to go and buy myself something that I wouldn't normally buy. And the more that I thought about it, the more I thought, why not get myself a new keyboard? It's something that I'll be using every day, so it's a good investment, and I can just see what this fuss has been about all this time. So I went out and I bought myself this keyboard. It's a Ducky Zero, which is in fact the same keyboard that my coworker had at the previous job. And sure, it was the same as any other keyboard, but as I got used to it, I found, it did make my everyday typing experience just that little bit nicer. And, I got quite attached to it over time. So, I was quite happy with this, and I figured, what more could I possibly need? Until I made the mistake of going on Reddit. So, if you're not familiar with some of the communities on Reddit, there's a mechanical keyboards community where people show off photos of keyboards that they've bought or sometimes even built themselves by getting the components and building it from scratch. And honestly, the stuff that I saw here kind of blew my mind a bit. I was seeing things like, these really cool compact keyboards that, had a bit of a smaller form factor and saved on space. Or I saw these weird things called ortholinear keyboards, where everything's arranged in a grid, or keyboards that were split into two distinct halves. And the more that I looked into it, the more I realized that this wasn't just about showing off or having something that looked really cool. People had all sorts of reasons for building or buying keyboards like these. The most common one was typically that you can customize the layout of it to be like anything you want. So if you have, certain shortcuts that you use a lot in different software, you can make them easier to use on your custom layout. Another big one is ergonomics, such as the split keyboards that we just saw. They let you keep your hands in a more natural resting position rather than having to kind of force them in to use a keyboard, which helps, prevent RSI and stuff. Some people would maximize portability, so they'd go for something as small as they could reasonably manage, so that they could take it to and from work without it taking up too much space in their bag. And after a while looking at these, you know, I got to be honest, I started getting a bit of keyboard envy. So I wanted to find a way to try and jazz up my keyboard a little bit. And so I went and bought a set of custom keycaps for my existing keyboard. It's just the same keyboard, but with a new set of keycaps that you replace and pull the old ones off and stick these ones on. And honestly, I was more excited than I care to admit when these came in, because it was just like, all of a sudden I had, you know, it was the same old keyboard, but it just looked really fresh and new. People would walk past and say, hey, that's a nice looking keyboard. And I'd walk in the morning and look at it and think, man, this is just really nice. But it kind of goes a little bit beyond that. Over time, a few more interesting things started to happen. So because I was enjoying using my keyboard so much, it made me want to find excuses to use it more. So I spent some more time starting to learn the keyboard shortcuts for all the various programs that I use. I started spending more time trying to learn how to use the command line properly, just because it let me use the keyboard more. And, you know, over time, I found that I did get, you know, a bit more productive or a bit more efficient at certain things, just because, you know, I wanted to use it as much as I could. And then a little bit later on, when I wanted to go to the next level and build my own keyboard, which I do actually have here, by the way, I was able to, you know, like I said, take it to that next level and try and create a layout that would suit me the way that I wanted, and got to learn a few things about electronics and soldering along the way. But that's enough about me. I only have so much time here, so let's get to the really important points here. This talk is not about making you run out to buy an expensive keyboard. Although I hope you find my story interesting, maybe you don't care at all about keyboards, and that's totally fine. Rather, I think the thing that made a big difference to me is that, you know, getting a nice keyboard just took a really common part of my workday, typing, and it just injected a bit of fun into it. Over time, that kind of gave me something to look forward to or get a bit excited about, and bit by bit, that helped me get better as a developer. So I'd like to put this to you. What gets you excited for work? Maybe it's as simple as just finding the perfect playlist that puts you in the coding mood. Maybe it's about picking that perfect color scheme for your favorite text editor. Or maybe it's about decorating your workspace with nice pieces of art that you just really like sitting by. These things might seem a little bit silly sometimes. I mean, I feel a little bit silly standing here talking to you about keyboards. But I think if you can find something like that, it's worth investing a little bit of time and energy in that. Because your workplace, you know, no matter how good it is, they'll never be able to make you 100% happy. So I think anything that you can do to get yourself excited for work and to make it a better place for you helps pave the way for you to be a happier and better developer. Thank you.
All right. So, my name is Dom. I work at Domain. We do a lot of property stuff. So, looking for properties, auction results about properties, everything to do with properties. And I'm also a simple man. I like simple ideas, simple sort of concepts. And what I wanted to talk to you about is sort of how using simple ideas and thinking about the past can actually help you with your day-to-day job and help you move forward. And I want to do this by talking a bit about what a project that we did at Domain. Now at Domain, it's anything but simple. We have microservices, microsites, we've got people and different teams working on each of these kind of microsites, microservices, data here, data there. Simple is not a word that I'd use to describe how it works. And when I started, I've been there for a couple of years now, I work in the web kind of area. It was more simple and it was more complex, which doesn't really kind of make sense, but what I mean by that, so when I was talking about all the kind of things we do at Domain, the different kind of problems and sort of products that we have, everything was in the one repo. So it was simple in the fact that when you needed to work on something, you just go there, you'd work on what you needed to work on, simple kind of dedicated pipeline for getting your stuff to production. And so in that way, it was simple. But after years and kind of lots of people working on it, it actually got very complex. You'd poke a hole here, something would pop out the other side. It was really actually hard to get stuff done, and it got a lot slower. And at the same time, we ended up having a bit of a dependency issue. And dependencies, like we all need dependencies, we need to get data, we need to do whatever, and you know, it wasn't the fact that we had dependencies and it wasn't the number of dependencies we had, it was how these dependencies had an impact on the application as a whole. So you could be working on something or one sort of smaller section of the domain application as a whole. It would have a dependency, say, on a common database, the same dependency that some of the more core sections of the site would have as well. A release might go out, and for whatever reason, it might do something like lock up the database or something, and then all of a sudden you've got this catastrophic failure just caused by a small section of the site which may not be the core kind of business. This is obviously a bit of a problem, and the way that we handled these kind of things was, as you kind of do, you try and be helpful. When there was an error, we had a nice error page and would provide a link to go back to the home page. Because we'd want people to go back and be able to sort of do other things that were not affected. For example, we had news, which was sort of on a different stack, which we get a lot of people to, so we want people to still, if we can be useful. But in one of these events, what would happen, you'd go to the home page, you'd click the link and bam, you get the exact same message again, which isn't quite as useful this time. Because it's the same thing, you'd just be clicking in this kind of, there was nothing to do, you'd get the same thing, and it really wasn't useful at all, it was a bit of madness. And due to sort of, like not this in general, not this specifically, but sort of how the business evolved, we started splitting up these applications. So functionality and products would go to different teams and are sort of chipping away at how the application as a whole was built. And when we got to time to do the homepage, we sort of sat back and had a think about what was actually important. And the first one, and something that kept coming back, it just had to be there. This was like the landing page of Domain or the front door, like we sent people back there from error messages, and it had to be something that was just always there. We kind of thought about this zero dependency thing, like I don't know, zero dependencies or close to zero as you can, and also had to be efficient. So in terms of like we wanted it to be efficient. So in terms of both the infrastructure and how it actually ran, but then also for a user, like how we got that to the user and how they interacted with it, we wanted to be efficient. So we're sitting around thinking about it for a while, and there's this bit of a common theme that sort of has come across at the conference. We got a bit nostalgic. And so we started thinking about the web, how it used to work, not just a couple of years ago, but like way, way, way long ago. And the idea of just kind of static pages sitting around. And it was very simple. It was beautiful, like simple and beautiful. Request would come in, get the content, serve it back to the user, none of these dependencies, nothing else. As long as a file was there, you got it to the user and that was it, it was there. But then obviously over time, like dynamic content, we had to go to databases, get data, do whatever, like the content, and it evolved. And I'm not saying static is the way to go, like it's obviously, it's not a solution for everything. But then, like dynamic, like it's not very binary dynamic. It doesn't have to be binary. It can be a bit of a range. It doesn't have to be dynamic or not or static. And we're thinking about like the homepage of Domain, and it is Like, it's a very simple page. If you haven't seen it, it's a search box, pretty picture, and then a couple of strips of some dynamic content. And we're thinking about it, and was it really dynamic, or, you know, how did it work? And it's sort of more dynamic-ish. So this idea of, yeah, it's dynamic, but not really. It's like at the lower scale of dynamic, if you think about it like that. The content, well, one, the content didn't change like per request. It wasn't like always constantly changing. And it also wasn't the primary kind of, wasn't the primary sort of like core use of the page. That wasn't what people were there for, what we wanted people there for in the primary sense. So thinking about static, like that dream of static, and then a bit dynamic-ish, and trying to come up with a way, like, how would you combine these things? Obviously, to combine them, you just combine them, and you got dynamics. It was perfect. This is what I call it. Nobody else really seems to like it. But, and this is what we did. So in the end, at the end of the project, we just had a HTML file. It's just beautiful, simple. It's there. That's it. Like this concept of static, it's there, something from the past. And then the dynamic-ishness part comes in because we just regenerate that page every 10 minutes. So it's dynamics. It's the next big thing, the ancient art of dynamics. So how did we do it? So again, it's sort of a bit of we're in AWS, we use AWS a lot. So basically we just have a Lambda function. Every 10 minutes just goes, regenerates the page, so gets that sort of dynamic-ish part that needs to be dynamic, generates the HTML and just chucks it in an S3 bucket. So there we go, like that kind of idea, it's just there, that file is there, and then just every 10 minutes just overrides with the latest version, and that's it. As that file's there, it gets served. And then in combination with that, so we use the CDN to sort of route the request to the homepage to then just go to the S3 bucket instead of where it was going before. And because we got this kind of static kind of mindset, and it is just a static file, obviously we can cache it a lot. And what the benefits of that is, so it's not even us that serves the page very often. So as the requests come in and come back down through the edge servers of the CDN, we offload a lot of that to them. So in fact, it's like 98.2% of the time, it's not us serving the content. So it's like this kind of, yeah, crazy idea of like we just put it up and then let someone else just serve it out, and it's great. So and it also means that the content is closer to the user, so they get it a lot faster. And we can also, another layer of this sort of like resiliency and be there factor is that, yeah, even if it, for whatever reason it's not there, it just serves stale content. And it's not something like this pre-rendering or pre-caching. It's not like a new, like we didn't invent this or anything like that, but it's this idea of, yeah, it's like thinking about older kind of things and how they apply to your new problems. So it solved this problem of being there because it's just a HTML file, it's always there, also in combination with the CDN. We actually got 0 dependencies again, because it's just a file sitting there, it's great. And it's pretty efficient, so with the Lambda function, it just spins up, does its thing, goes away. We offload all the actual work of serving it to our CDN. And then, yeah, as I was saying before, like the content is really close to the user, just gets to them really quickly. Now, it's not without us. This is obviously not something you can just go and, like, it suits every kind of situation that you have, and there are a few problems that we sort of had to deal with. Makes some things a little more difficult. Experiments is one of them. So I like to experiment a bit with the domain, and so little kind of client-side experiments are okay, but then when we want to do something a bit bigger, or we don't really want to affect and load stuff in the browser and switch things around, so this gets a little bit tricky, but we just end up rendering multiple versions using CDN to sort of route and do that kind of stuff for us. Testing can become a little bit iffy, like locally, like more of the end-to-end testing. And then it's the thinking process of it, or sort of it's a bit of a different way of thinking. So you're used to this kind of dynamic, or like just this request response come in, you got a server, you can do what you want and then sort of go back. But this doesn't actually exist, but you're sort of developing it a little bit in a way like that, but then at the end result is a HTML file. So it sort of takes a little bit of thinking, different thinking. But overall, it's been a really positive kind of project. It's been about 1.5 years, I think we've had it up there, and it's overall, it's been really positive. And so what I just wanted to leave you with is remember the notion of remembering this kind of crazy, wild ride the web has been on, like from the start. And we've heard about like the history of the web and everything like that. And the idea of thinking about and trying to utilize simple concepts and think about how you might be able to utilize them. Because sometimes the answer to your problem is not always in front of you, but it's behind you. So that's it, thanks.
Cool. Hi guys, hope you can hear me okay. Voice is a bit iffy, so hopefully it'll be alright. So I'm Martin from SmartBear. I'm Irish, you might have guessed by my accent. It's quite strong. So I'm going to talk to you today about a top-down approach to end-to-end testing. So if you haven't heard of SmartBear before, we're the company behind SoapUI and Swagger. I'm sure some of the room have heard of these tools before. Mightn't have heard of SmartBear. I'm not sure about the name myself. So what we're going to talk about is end-to-end testing. So essentially, what is it? There's been different ways and people interpret what end-to-end testing is across, if you're a tester and if you're a developer. So we're going to talk about two different ways, being horizontal and vertical, okay? So first of all, there's a number of different ways of explaining what it is. The simplest form is testing the whole application from start to finish, okay? So understanding the actual user journey. If someone's accessing your app, if someone's accessing your web application or your desktop application, is it just the functional part to make sure everything's working? What about the back end? Or is it actually how they use the application on a day-to-day basis? So it involves not only just making sure a button's working, but also making sure that something has been sent to the database or the API in behind is working. So what if you log into an application like we see on the screen here? Okay, the login might have went through, but has that been posted to the database? Maybe there's a login API which has tokens in behind it. So we always have to take all of these areas into account. So we're simulating real user scenarios. It's not, that we're just testing one area, but actually everything together. So how a real user would access the application. So when we talk about the two different types, and I'll show this in a graph, which makes it a bit easier to understand, but we have the horizontal view, okay? And we also have the vertical view. So when we look at the horizontal view, this is really going stage by stage. We'll take a look at an e-commerce example from, logging in, creating an order, or purchasing or selecting a product, going through to the checkout. But what about everything in behind that as well? So it's a common case where we'll just make sure that everything's working successfully, but what about the API in the background? So maybe something's working functionally, but when we click something, no data has gone through. So really, this is the start to finish perspective, and it can be done from a single application or interface or an integration with a third party as well. When we talk about the vertical, which is more of what a developer looks at, this is where we're testing at every single layer. So we'll test at the database layer, we'll test at the UI layer, and we'll test at the API layer. So we're working our way through every different subsystem as such. We can work independently on each subsystem, and these tests include unit tests and API tests as well. So we need to have both to be successful, make sure that we're actually meeting that. So let's plot it out on a diagram and see how this looks like. So we have our horizontal and vertical, we named them just in case you didn't know what they were already. So first of all, we have our UI layer, okay? So this is the vertical side of things. When we match that with the horizontal layer, this is where we go ahead and do our search and our find. So think about looking through Amazon or any of these e-commerce sites. We're going ahead and we're doing our search and find, maybe after our login as well. Second, we're going ahead and doing our order, making sure that we are going to select our new pair of socks or our drone or whatever we want. The next phase is then from the vertical, we're testing our API, we're testing our verification through a third party that we're integrating with via API, and then we're going ahead and validating that we can actually get to that checkout phase as well. But when we look at the horizontal layer, we're making sure that we're getting that purchase. So what we're really saying is that we're matching the vertical and the horizontal together, but you can't go ahead and purchase something without making sure that you have enough credit in your account or your bank, okay? So when we take a look at how we look at this from a tool perspective or from a software perspective, this is an example of just we can call it an integration test, but if we wanted to map out a full user process, a UI and API layer underneath one test suite. So this example is just one of our tools, but you can see here on the left-hand side I have some keyword-driven tests. It can be done from a script perspective as well, where I have an e-commerce full script, but I can create a modularized test as well. So this could be just like a login test, or an order, or a logout in general. So rather than having this extremely large test, we can break it up into a more modularized fashion. But when we do that, we may only want to test one API or one database check in behind it. So what you can see here on the screen is a full suite that was executed, and it's showing some log information based on an API test with SoapUI that's done in behind, as well as Selenium our test complete as well. So how this looks like in terms of a logging and making sure that we're getting that correctly is on, firstly, the left-hand side, you can see that we've done some checkpoints to maybe validate a database in behind. We've also checked the functional side, making sure that the button is selected and clicked and working. And then we also have our API. So we are sending our request, we're getting our 200 OK, and then we're generating our response with our authorization using bearer, and we have our access token. So this is all collaborated in one platform, and you can execute multiple tests, validating a database, validating the functional side, making sure a button's clicked, and also validating your response, making sure that you're getting a 200, maybe it's a 401 or a 500 that you're getting as well. So when we talk about the top-down approach, you can interpret it as a bottom-up, meaning that you have all of your tests together and you can just pile it up the way. But really, we want to define the workflows first, making sure that you actually understand from a user perspective how they're engaging with your application and your e-commerce site or your app, etc., as I mentioned. So when we talk about decomposing the workflows, this is actually making that modularized test scenario. Okay, so you can go ahead and make the smaller test cases together and then combine the API or the database testing behind there as well. So really, you can't test everything if you're going ahead with end-to-end testing. So you need to select the different environments. So do you need to test it against Android, iOS, what different operating systems, what different browsers, and also what different resolutions. So select the actual tests that need to be relevant to you, select the operating system, select the browsers, and make sure that you're running the correct tests in behind there as well. So you can make a framework and based off this top-down approach. So what are some of the benefits of end-to-end testing? Confirming the application health. Again, we're checking from not only one area in the UI, we're checking from a number of different areas as well, such as the different layers that I talked about, database, API, and more different layers as well. You can expand your test coverage, meaning that you need to understand every different environment that your user is accessing as well. So not just one environment, but many different environments that they could be accessing as well. And detect bugs. So end-to-end testing can be done from a manual perspective, meaning that you're clicking together. It can also be done from an automated perspective. So if you wanted to pump this into your CI pipeline as such, it allows you to detect bugs before your users detect the bugs. So you're making sure that you understand the user journey, but you're making sure that everything is working before they find. And that's the last thing that you want when someone's accessing your application and using it on a day-to-day basis. And reduce test resources. So making sure that you're doing this from a limited amount in terms of monetary value, and making sure that you're doing it from a cost-less perspective as well. So making sure that you can do this at a very slim line in terms of monetary value. And what about the steps for success? So review the requirements that you'll be using, set up the different test environments that are required for your end-to-end test, define all processes of your system, describe the roles and responsibilities for each system, outline any particular testing methodologies, making sure that you have a standardized testing process, create requirements for tracking, and list the input and output data for each system. So when I talk about tracking, this is a very, very key area. So when we talk about metrics for success, test case preparation. So you need to go ahead and maybe, if you're using a test management tool, or if you're going ahead and just managing it from an Excel sheet, you need to be able to go ahead and make sure that you have the number of test cases within that test suite, or the number of different test suites selected. Understand the test progress, be it on dashboards or be it on specific reports that you run on a weekly basis, because again, how much time are you going to run this test? Is it going to be every day? Is it going to be every night? Based after your CI in general. and understand your defect status. So how many defects have you recorded within 1 day, within 1 week as well. So usually within a defect tracking system like Jira, etc., you can go ahead and understand that. If you want to pump that into a test management system as well, again, this is an easy way of managing that. And test environments. So managing the different environments that you want to host yourself, or even using a third-party tool to be able to host these in the cloud as well. So some of the mistakes that are often made with end-to-end testing: not including enough environments, so only testing across a subtle amount of environments, not having the right ones in play, focusing only on functionality. So rather than actually looking at the background in general, you're only testing on is something working, rather than did the data actually jump into the database, or was it posted to the database, or is the API in behind working. So when I log into my application, okay, the login button's working, but did the actual data send through there as well? And executing end-to-end tests prior to functional tests. So these are usually done following a functional test, because you can't go ahead and test every system while driving a car down a road. You want to go ahead and make sure that the car is working first as well. All right. So thanks very much for your time, guys. I hope you got something out of the session today, and great to talk to you all.
Everything's been very practical so far. Let us address that imbalance. Yeah. Cheers. Sorry about the delay. Okay, that makes me paranoid. I've been eyeing that all during this. It's like, no. Okay. Okay, turn the goggles on. Okay, let's go back. So, droning on about drones. I'm good at that. Okay, so where are drones currently used? So you've got the obvious ones, such as the military, photography. Will here does racing. So we've got a big race tomorrow. I also race. I take off. And anything beyond that's sort of, yeah, bonus. We'll see if we can make conference audiences nervous as well. So, with more and more industries using drones, now's a good time, I think, to learn how to program them. So, I'm not talking about autonomous. I'm not talking about autonomous controlling. I'm just talking about this PC, or a PC, controlling it. Being able to say, okay, go off and do this, take a photo of that, do whatever, and come back. I'm also not talking about the recent DJI and Microsoft partnership. So DJI make the Phantom drone. Sort of you've probably seen them around, big white ones, expensive, well, out of my budget, definitely out of his budget. And so, yeah, DJI and Microsoft did a partnership recently, creating an SDK, and so you can go off and program using that. Again, not talking about that. So, budgetary issues, so the DJI that I'm talking about, it's almost $2.5 grand. You can make your way down to a racing drone like this. Putting it all together, it might be between, I don't know, $400, $600, something like that. You can spend a lot more. We're talking about something a lot cheaper.
Like an 1810. Now, we're going to be trying to attempt to fly one of well, a smaller one of these, more like this. And the reason we can't fly these is because they're a little too powerful. We don't want to get booted out of NDC because it goes 40,000 RPM.
Okay. So, if you can get your goggles on. So, okay, give it a go. Yeah, here, I'll put the batteries in. Okay, so yes, because I don't know, well, we don't know how, could we swap the video feed? Not pick it up?
You have
Oh, what do we? Oh, okay.
HDMI.
So, plug it in. It helps. Yeah, take that across there. See, too many cables.
Way too many.
Okay. Getting the video feed yet? Okay. Well, this is currently. Do you have your goggles on?
Yep, I have signal.
You've got signal. Yeah. Okay.
Oh, yeah.
Okay, cool. So, everyone wave. So, yeah,
Oh,
okay,
great.
code demos live, they're bad. Try physical ones. Okay, so, hey, we lost signal again.
Yeah. Okay.
There we go. Okay, so because we don't know how familiar people are with drones. So Will's just going to, without falling off the platform, just sort of like give it a fly, take it off over to where people are not sitting, because I don't want to get booted out of NDC. Okay, so just take it off over there. So with the controller, Will's controlling pitch, or sort of thrust, pitch, yaw and roll. So you've got 4 numbers that are basically sent through. Can you bring that back now, please? I'm very proud with him, not trying to race around everyone. Okay, just crash it somewhere. That part of the demo's over. Okay. Okay, so that's what a human does with it. So what I've been looking at is, okay, how do we get a computer to send the same info? And it really is just 4 numbers. Oh, my ideal goal is to have for Will to have something to race or chase. So think of like an Xbox or PlayStation game where you've got a ghost of your previous lap. I figured out part of it, haven't figured out all of it. I'd love to be able to have a ghost of Will's previous lap and, okay, try to beat your lap time. That's what I'd like to do. How long that will take is another question. So how do we get the laptop to talk to a drone? So what we've got here is an Arduino, and I'm using that as basically the radio transmitter. And so the computer, right here, right there, it's just talking over a USB port. So if you can open up a USB port and send 4 numbers, from the computer's point of view, that's all it needs to do. It just needs to know which 4 numbers. Are we throttling up? Are we turning? Are we doing this, doing that? So it's very simplistic on the computer side, but that's actually where the interesting stuff is, to me at least. So like I said, 4 numbers, any language will work. If you open up a serial port and write 4 numbers, that is it. There's a lot of magic in the Arduino side, which I have to admit is beyond me. I'll cover that in a tick. Now, I've also really got to say that I am inspired / blatantly stealing of 2 existing GitHub projects. Now, we've got a consolidated link at the end that covers all this. So yeah, I'm heavily borrowing on 2 existing projects because I've been wanting to do this for a couple of years. I just could not figure out how. And sort of this project solved a bit of it, that project solved a bit of it, and I mashed it together. And hopefully it will work. So here's a little example of in Go. It really is a case of, oh yes, you open, you literally write number, comma, number, comma, number, comma, number. That is it. And then you've got to figure out, well, what else do you do then after that? So the Arduino gets those 4 numbers, and then it converts it into, in this case, PPM, which is pulse position modulation or something like that. I never remember it. That's a protocol that this drone understands. Now, it's not just the little ones, this big racing drone, that can also use PPM as well. There are other protocols we can use, but it's a starting point. So cover that. Now again, the Arduino code that does this, done by someone way smarter than myself. They've had to, first off, read the specs, which is always fun and interesting, but also reverse engineer the protocols. Because just because you can talk to PPM to this drone, talking to this one might be slightly different. There's enough nuances that, yeah, you got that one working, doesn't mean it's going to work with any of these ones. So there's another project. Again, there's a consolidated link at the end. This guy here, well, I think there's a team of them behind it. They create the Arduino code to be able to target particular drones or particular receivers. Very, very useful. And yeah, that's covering, so you can talk to multiple drones. So you could just say, oh, I need a variant for D1, load that up. From the computer's point of view, it's still, hey, I'm throttling up pitch yaw, whatever. It's the Arduino that then does this. Now, from the Arduino, even though there's a lot of complex stuff in there, I'm treating it like a black box. The computer side, it's a case of, okay, I wanted to do this, wanted to do that. I'm in the process of trying to get the video feed back into the computer and then use OpenCV to be able to not just, also so the computer can determine, oh, there is an obstacle there that I'm going to collide with, let's do something about it. As opposed to, hey, Ken said go this way, bang, we hit something. So, consolidated link, if anyone wants it, it's got this presentation and a bunch of other stuff. So, yeah. Now, we've tried this, and there's enough radio interference that this is not guaranteed to work. So we actually came in here earlier today and tried a few times, and it worked, and we filmed it to prove it works for any doubters. Okay, so let me just jump to, yeah, okay.
Yeah.
Oh, actually, let's see if I can power this.
Okay.
Let's just see, before we jump into source code, let me.
I hope this works.
Yes, otherwise I'll get abused for ages.
Yeah.
Okay. Okay, cool. You don't actually need to see that for the moment. We'll jump to the code in a tick. Let me see if I can power this on. This is the tricky bit. Is that on? It's flashing, but it's not doing what I want it to do. Oh, wait a sec. That's through there. That's through there. Whoa, this computer is falling off the thing. Hey, Will.
Okay.
I just want to try something. Hey, Will.
What?
Not bad.
What? Ah. What?
Because, yeah, this is all... Oh, okay. So there, you see, this is all programmed for particular COM ports. And I just need to make sure that it's going to work. Okay. Turn that on. That's better. Okay, cool.
Okay.
So, actually, if we could go back to the computer. Thanks. Okay, so let me just check something. Okay, cool. So throttling up, that's one good thing. Okay, so I'm about to run a program called we've got a method here called throttle and pitch. So we've got our four numbers. Now, 1500 is basically the middle of the road. So if your pitch is greater than 1500, you're pitching forward. If it's less than 1500, we're going backwards. So in this case, throttle 1800, so we pitch, throttle's up, but then elevator is also 1800. So it should be throttling up, and going forward.
Yeah.
Then, okay, and you'll see that it's literally, okay, it makes a command of number, comma, number, comma, number, and so on. Now, Arduino here, that is just the open serial port. So that's all that is. So I send the command and then I sleep for 2. So it should do that for 2 seconds. Then I change it. So I give it a little bit more throttle because I've found that I'll be dipping down a little bit here. Don't my luck, it's going to hit the ceiling. And then the pitch is now 1200, so it's less than 1500, and so it should come back to me. It'll sleep for 2 seconds, and then basically I'll knock the throttle to 1000, which will knock it out of the sky, and in theory, I'll be able to catch it without diving and looking like an idiot on video. So, This is nervous. Okay, can the people in the front get ready to catch this? Are you serious? No, I'm not really going to do Jesus.
Think common sense.
Yeah, I was about to say, I wasn't going to let a human fly over you. No, I'm not really doing So, you can dive and look like an idiot, okay? Okay, so let's just try this, and don't fall off, Will, please. So, in theory, if we do this, go forward 2 seconds. Oh, the battery's running out. Oh, damn it. We'd already practiced a few times, so the battery's a little dead.
There you go.
I've got other batteries, but I'm not going to bother doing that now. But
Yeah.
okay, so you can see we pitched forward for however long, and then pitched back. So you can, again, these are just 4 numbers. Your role, you can start doing it. Now, if I started trying to do what Will did, there were so many waypoints that he just naturally did with his thumbs. So it's still have to figure out how to do this in a controlled way, but the point is that sort of once the Arduino, it's the black box, it's talking between what the computer wants to do and the drone. It really is simple. Open up a serial port, start pumping out the 4 numbers, and you can start sending these little $20 drones about the place. Using OpenCV that's going to be the exciting bit later. Anyway, that's it. And fortunately, I didn't need to use my last slide, which was all sort of not enough goats. That's it. Thank you.